Hello, Dada. We will begin at 6:40.
Yeah. Can you hear me, Crash?
Yeah, yeah, yes, Dada.
You
Yes,
can hear you. Okay, you can hear
yes,
me.
sir.
I cannot hear you.
Uh, am I audible?
Wait, let me fix it.
Okay, sure, Dada.
Um,
Uh,
yeah, now I can hear you.
sure, Dada.
Wait, my stupid mic. Okay, how many do we have? Really? Hmm, that's a lot of people. Wait, wait, wait. Let me share this. Oh, wait, I have the link. Hmm, Actually, let me share the link on my speakers
Sure, Dada.
in case anybody is interested to them for some reason. By the way, like, what's the distribution here? Like, I mean, like, do we have people from first year, second year, small second years?
Uh, there are a couple from third year, and
Huh.
majority is from second year.
Majority
One
from
or
second year.
two
Yeah,
might be from first year who are yet to
great,
join.
great, great. Okay. Second year is fine. It's good. Uh, okay. So should we start? Everybody has joined, or should we like wait for 2 minutes maybe?
1 minute. Yeah, we gave
Okay,
6:40 as the
1 minute.
final. 1 minute.
Somebody do the 60 seconds countdown now. This guy is on clock. So how's life, man? How's the AC?
Uh, well, till 1.5 months ago, it was fine. And I mean, for internship, we are out for internship now.
Okay. Like you said, like till 1 month ago, AC was fine. Now it's not. I'm like, what happened? Right.
Means my information is a bit outdated too.
So the worst can really happen. Just like that.
So, firstly, I guess one of our members will give a brief intro about you, Vidya. We will start regarding the newer students who haven't yet means known, always doesn't haven't been known about you. Vidya, would you please start?
Yes. According to Alfred Aho, computer science is a science of abstraction, creating the right model for a problem and devising the appropriate mechanizable techniques to solve it. Good evening to everyone. I'm Bigga Bora from AEC Coding Club, and with me I have Meganka Da as my co-host, and we welcome you all. Today, engineers rely on computers for much of the processes. Using computers and especially computer software, engineers can design, test, and make changes to products in minimal time. In view of this, we, the Assam Engineering College Coding Club, in collaboration with GDSC AEC, is going to organize a seminar on scaling CS fundamentals to real world and the missing bits today. In this program, our guest of honor is Rajat Kanti Bhattacharjee Dada, an ex-alumni of Assam Engineering College. Again, a very warm welcome, Dada. Thank you so much for giving your valuable time. First of all, I would like to give a brief introduction about him. Rajat did his BE from our renowned Assam Engineering College in the year 2019 by securing first rank in the Computer Science and Engineering department and second rank in the university. He also secured third position in All India level competition Ideathon organized in IIT Delhi. He was also the ex-secretary of AC Coding Club in the session 2017 to 2018. His publications were Handloom Design Generation Using Generative Networks, a framework for maintaining citizenship records on blockchain, a secured land registration framework on blockchain. He has done his internships from Indian Institute of Technology, Gandhinagar, Indian Institute of Technology, Guwahati, Indian Institute of Information Technology, Guwahati, etc. He has a lot of experience as a software engineer in different companies like Gojek, Typito, etc. Currently, he is working as a software engineer in the share chat. He was also project engineer in Assam Engineering College. The project title was Object Motion Detection Framework. Now, I would like to mention some agendas of our club. These are mainly to make some stuff about need for inculcating coding habits and industry skills in the students, forming a group where students learn from each other. And we are trying to connect students to with alumni with industrial experiences and so on. Thank you. That's all from my side.
Yeah. Wait, Megango, is he saying something? Megango, you're on mute. Uh,
Mriganka,
Megan,
unmute yourself. Mriganka, I guess he might have some issue on his technical
oh,
end. Yes,
uh,
Am I audible this time?
yes. Yes.
yes.
Yeah. So I was saying that thank you, Rajata, for being able to take the time out of your busy schedule to be among us and guide the juniors. Also, before moving on to the great presentation, I want to ask you one thing personally.
Yeah, sure.
How do you feel to be like
Wait,
though
Megango, your voice is
virtually? How does
breaking.
it feel?
Your voice is breaking, so I couldn't get you. Should we
Okay.
start or like,
Uh, Basically, he was thanking you for let me be
okay,
instead. So thank you, Dada, for coming with us on such short notice and also out of his big schedule. Your sessions have always been inspiring. In first year, we attended your session. It was a big booster to other. We hope our juniors also got a similar vibe from this session. So I guess you can take over.
yeah, yeah, let's hope. Wait, let me share my screen. Later. Can everybody see my screen?
It's visible.
Okay, great. Somebody just keep talking to me because otherwise, like, I'm not able to see this particular screen, right? It's always this one. Yeah. Anyway, let's start. Okay, so today's, as like we all know, we'll be talking about CS fundamentals and how they really scale to the real world. Before that, like we already got a like really long introduction of me. Even like I'll just condense it down for you for now. I'm a software engineer, right? Currently working at ShareChat, and I just joined ShareChat 2 days back. So yeah, I, the last week I was working with Project. In my short duration of like, and 3 years is a very short duration of working as an engineer. I have actually switched to many different places. I always keep pursuing the problems that interest me. If it doesn't, I leave. Uh, Apart from that, I really like computer science in general. So, which means like I am somewhat like most people would call this as polyglot way of doing things. I don't like to call that because polyglot is a lot more than what people think it is. I mean, the last known polymath is what you call is like someone who's good at all different things is was John von Neumann. So definitely not that. Yeah. So I try to do a lot of things, whatever interests me. You can connect with me over LinkedIn. That's my ID, and that's my Twitter ID. And don't ask me why I named it Simple Guy. I just like it. Okay. Disclaimer. I just prepared them an hour back. So they were typos. Not that if I wouldn't have, I wouldn't have made the typos. I would make the typos anyway. This is completely personal. Like I mean, these all the opinions that here are completely personal, and yeah, you should be aware of it. Most of my experiences and the instances that I will share are pretty much real, but I'm not sure whether the companies are alive or not. Like alive or sold out. I like yeah, no idea about this. So what are we going to talk about today? Okay, so first we'll start with some of like minor, small, simple problems that I solved and came across, and that might give most of the people here some clue onto what are really relevant in your course, right? And this is again like very specific to your course structure. Like my entire all the slides will like whatever I show you I'll tell you that what part of your course should you really focus on so that you can get a better understanding. So it's completely fine if you do not understand it right now, but know that whatever I'm telling you, you can easily Google them, and then whatever concept I tell you, you can always find them in your own course. So this is the entire like the the top point of today's discussion and like interaction is that I want you guys to understand that how the CS fundamentals play their role in everyday an engineer's life, right? So first we go to the tiny problems, then I'll also talk something about from my recent experience and talk about in general how can you have systems understanding, and yeah, like if there is more. So yeah, that's it. Great. Was there a thing? Just do share it also. Never mind. Okay. Sure. And start. So problems from past. That is like in my early days, what kind of problems I came across, and sort of realizations that I got. And not just realization, I kind of knew that, but that was like a first instance that I saw this. So this will be one, right? On the left, you are looking at a standard Geeks for Geeks problem. Minimum number of platform required for a railway/bus station. I really would like if everybody could just Google this problem, right? You'll probably find this on Geeks for Geeks very quickly. Prayash, it would be great if you can actually share the link maybe, right? And
On it today.
yeah, and below you can see is a video editor. And I actually am using the video editor on which I worked on, but most video editors, if you have worked with one, will have this timeline view, right? You can see these capsules, right, being laid down. So the question is the minimum number of platform problem, and the way this layout works, are they any different? So I would like to everyone to just go through the problem first. Okay, let me just share it and let me know that if it makes sense. I mean, yeah, are you able to read? Is everybody able to read this particular statements, or is the font too small? Because in that case, Prayash can share the link.
It's readable there. I also have
Okay,
shared
great.
that link.
Okay, great. So go through it and let me know that whether this problem and this particular UI element, where you see a bunch of capsules being laid on top of each other, are they really different? Because like I can obviously give you the reveal there, but I want you guys to at least think about it once. Take your time, maybe like 1 minute, 2 minutes. Okay. Probably people will be tapping about in the chat. Okay. So I'll just present and give you the spoiler for the answer. The answer is yes, they both are same. As a matter of fact, whenever we are actually creating this UI element, right, this UI where we actually lay down each of these capsules. So these capsules are basically thinking about that there might be probably like in Photoshop, you can add bunch of images together. You can add maybe in After Effects, you can use put together a bunch of videos. So these are actually that, right? They are actually determining when does the image start showing and when does it stops. That's it. That's just a visual cue. Now the thing is, we need to figure out, for example, if I have 10 such kind of elements, right? What is the maximum height or the maximum, tracks do I need to really create to accommodate all of these elements, right? And the data, the way it is available is exactly like this. You have a beginning, right? A beginning time of the capsule and an ending time of the capsule. And then you just figure out like how many tracks do you need, or in this case, how many slots do you need, right? And turns out the actual implementation, even currently in the software, is not the optimal answer. It's the n square one. So bummer, right? The optimal answer is of n log n complexity. I hope like everybody is getting it, because the complexity is something that you get introduced in second year itself. And like from what I understand, most of you are from second or third year, or from first year. So yeah, I guess you might get the idea that the optimal answer for this comes in O of n log n, the most complexity. And the answer that the implementation we were using was O of n square. Now, I'm not talking about in terms of optimization, but think of like this: is that these this particular problem, this came out of nowhere, right? Like we just saw that okay, we need to do this kind of layout, but the answer laid in completely something different, right? And it was something in a fundamental subject that you study in, just your second or first year, right? I think in AEC it's still in second year because you get the basic engineering courses in first year. So yeah, it's you probably study this in second year itself. So see that, like, I mean, if you study it properly back then, if you get a good understanding of algorithmic complexities, so basic sorting mechanisms, and just in general have a good sense of problem solving, I mean, you would not write the O of n square in the first go, and you would be better equipped to actually spot these problems. So whenever you see some problem, right, like some such kind of requirement comes up, and then you see like the algorithms, I won't say the algorithms would put like, immediately pop up, but you would be very good at identifying what should be really the complexity for it. You might not be able to figure out immediately, but you would be really get good at figuring out the complexity. And when you figure out the complexity, right, you already start to guess about what you can throw at it. So whether you can throw a hash map or a sorting algorithm or a tree or whatever, like you know what to throw because you know the complexity for it. So yeah, that's why like algorithms are important. They are fundamental. Do not skip. Do not ignore. Even if you are thinking that nahi, meko to sirf front end karna hai, I just want to do front end. Like this is the front end. You're looking at the front end. So yeah, you're welcome on that. Next thing, data structures. So data structures again comes up like there are some basic data structures like hash map, tree. I won't consider array as a data structure exactly, but yeah, hash map and tree being the most popular one. Linked list. So these things are common, and ideally you should pick them up. Now this is an example of where will you really see them when you're actually practically working with something that generally people don't relate with data structure. So in the bottom right, this is how React, right, works on your DOM nodes. So for people who do not have context about DOM nodes, when you see an HTML, right, you write bunch of tags, h1, h2, give me some other name here, h1, h2, then the header, then body. So these are all tags, right? Now, if you think about it, if A1 is the body, B1 can be the H1, B2 can be the paragraph, right? B3 can be another item inside it. So effectively, it's a tree. What React does is that convert it into a list and then iterate on it. And turns out this is also a geeks for geeks question. So again, like the same idea, like you cannot really escape data structures. You might not always require to write this again unless you're working with the React team, but you will have to know like these fundamentals will scale and be like sticking with you wherever you go in whatever cases. Like I'm particularly showing for the front end because people generally think on front end these things are not present, right? So I don't know why people think that, but yes, probably because of the interviews. We'll talk about that as well. But I guess this is quite clear, right? That data structures are important, algorithms are important, and data structures and algorithms are not just important for cracking the interview, but beyond that as well, right? That's why I'm showing these examples so that you guys get the notion that it's not just about the interviews, right? And yeah, okay, I missed that thing. Okay, and there is more. So I'll share the link for this. Wait, let me see if I can share it. Anyone needs copy link. Yeah, I hope everybody got the link. Yeah, whatever. Okay, so there's more to these kind of stuff. Like I was actually about to talk about hash tables, but I don't think I should go much deeper into it. Like considering that we want to include it as well, and I really want to have it more interaction with everyone here so that I can entertain their questions. But if you have used any programming language like something like Python or JavaScript is quite popular. So you might have used something like object, right, or dictionary in Python. They generally are treated as a hash table whenever you're using it. So this is just an article I'm giving in the link, like the one that I've given. So this analysis is a link to it. you can actually read about how they are how these various languages are implementing it internally. Now, it might not be always important to know, but again, coming back to the earlier point, right? You won't be implementing a hash map, but it's good to know. As a matter of fact, when you're using a language, it's really good to know that how that language behaves and implements a lot of the things that you are using, right? Because in the end of the day, you are going to use an API. What's more important, and what many of the junior engineers misses out on, is that they do not care about what's underlying the API. They just look at the library, look up for it. Oh, I'm going to solve this. Is there an API library? You import it in and problem solve. Good. That is efficient actually. But if you don't know what your library is doing inside of it, you don't know which one's the best one here. We're going to talk about this like dichotomy of choices, like which libraries to pick up and all later, like in the QA section. But right now, this I want everybody to understand this, that you need to dig deeper in general. And if you want to dig deeper in your software career, like if you want to progress, you have to dig deeper. And in order to dig deeper, you need to know algorithms and data structures. Hence, what I want to convey in the end is that it's not just about interviews. So yeah. But yes, you'll still require them for interviews. That's like you need them. Okay. Now I'm going to talk about things that I faced more recently, right? Uh, that's basically me as a systems engineer. And for anyone who's wondering, like, well, okay, we're talking like I am currently working as a software engineer. Then why I'm using the systems engineer term here? So when I say systems engineer, it generally mean I was not working on an application. So previously, the one that I showed, right? These are applications. So this is a video editing application. Your mobile has a bunch of applications. So at one point, I was working as a application engineer, is what you can say. But recently, like around April when I searched, I was working as a systems engineer. So I was working more on the system side of problems. When I say systems, I mean my daily work involved looking at some kind of problem which always got resolved by my understanding of what the operating system was doing, how the software was interacting with the operating system, or the network topology, or the architecture of like which CPU we are using, so on and so forth, right? So that systems understanding comes into picture when you are acting as a systems engineer, right? Your title might be software engineer, but you might be acting as a systems engineer as well, right? So that's why I use the term systems engineer, and that is basically how systems engineer really looks like. You're just looking at them, staring at a screen, doing nothing. They're actually doing something, but on surface, that's how they look like. Okay, so this is where like I mean things things might go out of context for a lot of people here. So I want to first actually just to get a confirmation on how many people have heard the word or heard about the software called Kafka. Like, I mean, how many of you guys have really heard? Like, if you have heard about, you can just like ping yes or yeah, have heard, have worked, something like, yeah, that would be great if you can do that. There are like 47 people here. Would be great if we can. And that is completely fine if you say no, because this is something that like a second year student is not expected to know about it. Okay. Okay, so I'm guessing like not a lot of people have really heard about it, but you can always Google about it. What Kafka does. How many of you have really heard about message queues? Uh, any kind of message queue? Have any one of you worked with them? Okay, I'll just give you a primer on the message queues. So message queues are basically, I mean, if I have to simplify, as a matter of fact, I'll actually simplify this. At my previous job, I was working with the events platform team. And if I have to give you a rudimentary understanding of what an events platform team was, it was the Indian Post Office Association or organization. Yes, like we are the like the Post Office Association. Kafka here was the truck or the transportation medium, right? And basically, everyone's application. So someone's writing something in Node.js, someone's writing something on some other language, and they want to communicate to each other. So the Node.js application wants to tell the Golang application sitting in Taiwan that hey, something has happened, right? So it wants to send a message or a telegram in the post office terminology, a telegram. And we as like the post office association, we are like, okay, we have the trucking system, we have the communication system laid down for you. You just need to make sure like you're delivering it to the right post box so that it gets picked up and get delivered to the right place. And that's this entire delivery thing in like in general software systems is handled by a message queue, and that's what it is, a message queue. The the guarantees are that if the message is given, it will reach. Okay, you when later you guys get introduced to more advanced concepts like distributed systems and distributed processing, you will even realize about the that guarantee of that message bheja to message milega is very hard to achieve. It's not that easy, right? But Kafka is one of those things that constitute as the truck for the Indian Post Association. That uh, it was basically the that transport system for us. Now, here's the thing: a lot of people use Kafka, right? I mean, after, for example, you graduate, you go into software engineer, there is a high chance you will come across it. If you are working in a organization that's even like that has a user base above an active user base above 100,000, right? 100,000 in a day, chances are you're going to have Kafka, because by that time you might have already started to go into microservices, right? I won't talk about microservices exactly here, but to put it simply, you have one node application, you have one Golang application, they just want to communicate to each other. Why you are doing that? Because your team is much more larger. And for example, you might know something, I might know some, like you might know one language and I might not know that language. So I want to write in the language that I know. So to enable all the teams, generally applications might be written in different language. So Kafka comes into that context, and chances are a lot of you are going to use it. And here's the thing: a lot of people do use Kafka, but they don't know what it does internally, right? And what it does is very fascinating. Is first of all, thing, how many of you have an idea that how slow disks are? I hope a lot of people. Okay, Arindam Mobile, is it socket.io? So socket.io is a package, right? It's a package that's achieving a few things. Is that it's trying to use the WebSocket protocol, and if cannot do that, it will fall back and still give you the same end-to-end connectivity with the server, which is like both end-to-end connectivity as in like duplex connection. So you can send message from the client and also get it from the server as well. So it's not socket.io, but you can think of it like kind of a single server sitting and exposing a socket.io connection. You can think of it like that. So that single server becomes the broker. It becomes the arbiter between one server and the second server, and basically communicating between these two like servers. That's it. So Kafka actually effectively is that. I know like this might actually go beyond that, but I'll like yeah. So my question was actually how many of you really like have an idea of how slow disks are, hard disks in general are? Can you give me a ball? Can anyone give me a ballpark figure that how much time does it take to read from disk and get a data back to the memory? Does anyone have idea about it? Or if I give you that, which one is slower? Memory, cache, disk? What will you say? It's an open question, by the way. In just three, what do you guys think? Like, which one is the slowest one?
Disk.
Okay, correct. That's fine. SSD is faster. That's all I know. Okay, great. Okay, this memory cache. That's yeah, that is effect. That's correct, Raj. That's thanks on that one. So disk is slow, right? I mean, cache is fast, memory is faster, the disk is the slowest one. And to give you a scale, cache accesses are generally under 1 to 10 nanoseconds. Uh, Memory accesses generally go till 100 to 200 or sometimes like 500 nanoseconds. Disk accesses can go till milliseconds. I mean, at worst case, right? They can get really slow, and these are numbers from the older edge hard disk. These days, SSDs are much more faster, as one pointed out that SSDs are faster, which is correct. But still, SSDs are slower than memory, like your RAM. That is your memory. But Kafka does something awesome. Awesome is that Despite doing write to disk, it is not slow, right? It's writing to disk, and yet it's one of the most fastest message broker out there. I mean, if you're writing to disk, right, you should be slow because you already like have it, and it's actually doing a blocking IO. So blocking IO mean is that you get a request and then you write it and then you let the other person know. So person A sends you a message, you write it onto your disk and then send it to person B or application B. So that blocking IO, like we already know that the disk is slow. So how is the communication really fast? And here's the thing, that when I asked about the question that whether disk is slow, I did not ask is for what kind of writes. And this is something that you're going to come across in your operating system classes, is that disk management is a big thing, is a big part of how operating system generally hides away the complexities of a disk access, right? You generally don't care that what kind of disk you're accessing and at what rate you're accessing, what are the intricacies and the problems that are associated with it, or in general you just expect that it is slow, but you don't realize that whether it's actually trying to optimize it. This is a good example of it, is that when we say disk is slow, we are actually talking about random reads or random writes. Doing something randomly on disk will always be slower, right? But if you try to do sequentially, then it's not. So what I mean by sequential is that you have a disk drive, right? You have that CD drive, like I'm talking about hard drive here. You start from point A and then it keeps rotating, right? So if you sequentially write, it will just rotate. But if it is random, it's not just rotating, it's going zigzag from point A to point B throughout the entire disk, which is much more slower. And it's a very fundamental concept that like you'll read in your operating system book and might even forget. But the thing is, it is something that's widely used and like comes under the underlying fundamentals of why Kafka is pretty fast despite writing things on disk. And the reason it writes on disk is for recovery, because disks are resilient, right? Okay. The next point is okay. How many of you had your operating system classes by now? Without the context, how does file systems impact the disk drive? Crash, it'd be great if you actually ask the question, like because I'm not really ask the question as in like verbally, yeah,
Okay.
because I
So
cannot
that
like I'm not always reading it, right? And I don't think a lot of people are reading it as well. So
I actually did not interrupt while you were speaking on
that's
screen.
fine. Do interrupt, please. Otherwise, yeah, do deliver.
Sure. That.
Yeah, you're asking or something. I didn't read the question at all.
Okay, so basically, Dada, recently I realized means I currently on a Butterfly based system. So, how does means the file system generally impact or has the impact on the disk write speeds? So means I heard that Butterfly they did something that the write speeds are faster, but it sometimes it may take long time while deleting.
Hmm.
So this is something I recently encountered, but I haven't gotten much into it. So I
That
actually
is correct. Actually, file systems do impact greatly. So, like any specific thing you wanted to know, or
means
like
what this means the layer actually how does the file system layer the means interacts with the thing little bit.
okay, okay. So, the file system layer, like effectively, is actually a data structure. It's a big ass data structure of just telling how many sectors we have and how many segments we have. I mean, this definition will change for an SSD because SSDs are laid out differently. But that's what like effectively a file system does. Like it keeps a track record of these. The way that it keeps a track record of these will like comprise a lot of how the underlying the disk is used. So think of it like this. Okay, I'll actually give you a real life example. So Red Dead Redemption, if anybody of you know, it's a massive game, right? It's a 150 or like 132 GB game, right? Now, do you think that the entire 132 GB is sequentially after each sector? So a disk, right, generally has a segment and sectors, right? And so it's not that all of them will be laid out one after another. But here's the thing: if the file system is capable enough to actually really achieve that by identifying that yes, we need to fix the holes. So we need to fix the fragmentation, and that's what we, like I was coming to. If it can identify that that fragmentation needs to be fixed, and the files for Red Dead Redemption needs to be laid after one after another, like as close as possible, then you're going to get really good experience when you're playing. They will have no stutters ever. I mean, if your disk is fast enough. So that's how the file system really impacts. I mean, certain file systems are good for certain kind of hardware, right? Because those hardware have different kind of read-write latencies. So your file system access patterns, sorry, your file system data structure might also depend on that. So this is something you will actually come across in your operating system class, and that was actually my question. That how many of you guys have already come across your operating system classes? Guys, anyone? Again, I'll just repeat the question. How many of you guys have come up, like already done your operating system classes or have come across your operating system classes? Not yet. Okay. 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 Great. Uh, Actually, you know what? I'll give you a primer on that. So here's a question for you guys. In Intel i3, right, with 4 core versus Intel i7, 8 cores. Actually, that's an old data. These days, it's like much more better. It's like 16 cores or 10 cores or 12 cores. Yeah. But let's take these as an example. i3 4 core versus i7 8 cores. Which one will be faster? Simple question.
I7 8 course.
i7 8 cores. Okay. That would be a fair, correct assumption, right?
Depending on the type of program, does it utilize multi-threading or not?
That is correct as well. And we are actually about to talk about that only. So in front of you, you're actually looking at two different programs. One is like, as Brash wrote, is that one is trying to utilize threads, right? The other one is also trying to utilize threads. We're going to talk about that, how you should not really utilize threads. So this is, so you can see this one, right? Okay, I hope everyone can see that. So on your left side, you have consume parallelly, right? We are, and consume parallelly actually takes an ARR, an array, and okay, I actually wrote it wrong. It should have taken the array, but just assume it's getting the array. I made the mistake. Never mind. Yeah, and you're actually giving the beginning and the ending index for it. So you have a big ass array, and you're basically taking chunks of it to consume and do something parallel. This is actually Golang for anyone who don't know about the language. When you do a Go and some function name, it's going to spawn a separate thread and run it, right? We're doing the same thing on the right hand side as well. The only difference is that this time we're actually copying the array, right? And as someone pointed out that i7 is faster, correct. i7 will be faster versus an i3. But if the i3 is running the right, the code on the right side, it might just be more faster. I mean, it might give better latency numbers. Might, because again, we just have 4 items here, right? So that 8 cores is not getting well utilized, right? So that i3 might win. And here's the reason for it. And this is like, so that's why I quoted that your OS class is in action. Is that what's happening here is that you're hinting to the compiler compiler, and also like the compiler, whatever code it compiles onto, it will also try to achieve this, and your operating system and in general your system will try to achieve this, is that you see the copied array would lay in the cache of the individual cores. And you see, we discussed it a while back, right? That caches are fast. They're bloody fast. 1 nanosecond is pretty fast, or even less than that, right? And if you get direct access to, like if each thread gets direct access to those caches, so think about it, how fast it will quickly churn through all the data. On the other hand, if you look at the left-hand one, this array is 100, right? It can totally happen that it is not able to reside in the same cache, right? So it might be even moved to the memory, right? That's the worst case. And at best case, it might just still lay in the L2 cache because L1 caches are very small, right? So it lays in the L2 cache. Now, I hope everybody has heard about L1, L2, L3, these kind of caches schemas. If not, please read about it. They're very interesting stuff to go about. So yeah. So the point being that effectively the data lays in a slow space. The space itself is slow. So any processor trying to access the data will have a hard time reaching to it and hard time getting it back. So how can you have a really fast execution there, despite the fact you have multiple threads, right? So the idea of cache locality is somewhere getting broken. So that's your OS, effectively OS classes would actually talk about these as well. What we call as a memory management. The entire section is called as memory management. So we'll see that how from cache to this memory layout mappings happen, and then how does that goes into virtual memory mapping, uh, and that is what the operating system ends up using. So again, these things are very interesting. Like if you pay heed to those classes, then you can actually easily explain this. And here's it, like really, I mean, honest truth, not a lot of people can reason about it. It's pretty basic, but not a lot of people can. If you do that, really, it will help you down the line writing good software in general, right? And like it will help you not just like writing software in the it it will also give you a good perspective towards reading others, and not just others but like code for uh, softwares which really try to churn out the most amount of performance for the machine, right? So again, like, never, do not ignore your OS classes. That was the point, right? So these are things that you will come across in your OS classes. So those CS fundamentals are not exactly useless. This one doesn't have a separate slide, uh, but how many of you? So I hope that this might actually be something that we can interact about. How many of you use Node.js? Uh, I guess someone of you have definitely tried or used Node.js. That yes. Please tell me a lot of people have used Node.js. It's like pretty easy platform to work with. Okay, great. Um, Arindam, Prayash, like you guys have heard of the idea that Node.js is single-threaded? That's actually a question, by the way. Have you guys heard of that?
I have used Node.js, but I have never encountered such.
Okay, good. So like as more you keep using it, right, you will realize like, and this is a common trope that people will even criticize Node for, that Node has just like one single thread, like the program, your program, whatever you write, right, the JavaScript program, it will effectively just use one single thread of that i7 machine to run your code, right? So that 8 other 7 cores are sitting idle. I mean, this is just on a high level. How many of you have used Redis? Have any of you Redis? It's a very popular cache. Okay. Um, so I'll just explain quickly. So Redis is the cache implementation. So when I say cache implementation, to think about like this: if you have a database, right, with close to 15 million entries, and all you want to do is just grab some user data, right? Or maybe some kind of query you have written, some kind of SQL statements you have written. You want to grab some data out of that database. You don't always want to reach out to the database because it's a slow access. We already discussed that this is slow. So why not create a memory pool? Basically a sector in the memory, or a machine which has a lot of memory in it, or a lot of RAM, and then just put that data there. And whenever required, and whenever we know it's the same query, we just access that memory pool. That's effectively what cache is, right? Now, as for Redis, like, I mean, hope cache, I'm able to communicate cache really well. Like, yeah. But as for Redis is a very popular and very scalable cache, and that as well is single-threaded, right? Um, and the answer for how do they really scale is Node largely does IO bounded workload. So almost every server does that, right? And Redis completely leverages the idea of cache locality and zero contention, which wins over multi-threaded architecture. I know like this might go overhead for some people, because like I feel like a lot of you guys have not been really introduced to these concepts as of yet. But to put it simply, when I say cache locality, what we discussed a moment back is that if your code and your data lays in the cache, is going to be the fastest running code in your entire machine. Zero contention means here is that if you have two cores trying to grab data uh, onto the same memory space, you are going to have a condition where you basically like two people are running for the same cake. Like cake का last piece बाकी है, pizza का last piece बाकी है, and दो लोग उसके लिए भाग रहे हैं. So you have that condition there. And contention never helps, because two people will be quarreling कि मेरे को चाहिए cake, मेरे को चाहिए pizza. Like two people are just quarreling, nobody's getting it. So it's just time wasted. So that's contention. If you have just single thread, like if you just have one guy in the room and just one pizza and the last piece, you just go and grab it. That's it. And the next guy who comes in, he's like, pizza nahi hai. So like, ठीक है, pizza के लिए वो wait करेगा. But there will be no contention. There will be no, two guys quarreling, and you like everybody is like looking at it like, why you do that? Right? So that's what like zero content. The idea of zero contention means. Two cores will not fight for the data, will not try to get a lock onto the data. Just one core trying to get the data, and if that data is in the cache, good, great, that's the fastest you can go. And that's what Redis is about. Same thing IO, and all the things that I'm talking about, right, again comes up, is going to come up in your operating system and partly in your computer architecture classes. Question is, do you need them? Yes, these are things that are used daily, like almost every day. And the bad part is that not everybody can really reason about these. It's very difficult to like sometimes to even work with people who cannot reason about this, because they sometimes end up creating very overly complicated solutions sometimes, right? And that hampers the team, the software in general in the long term. It does hampers. So these kind of reasoning again really helps. So if you focus your operating system and computer architecture class, that will always help you in the long run. Yeah, I actually was about to talk about these as well, but yeah, there are just more terms you're going to come across, and like these are the kind of terms that you will ask here. तो मैं कभी करने वाला हूँ ही नहीं. Like normal forms, boy Scott normal form. Yeah, this IEEE 785. Right? I don't know IEEE 785 to be honest. Like I forget IEEE 785. It's a spec basically, but I understand what the impact of it. But yeah, I myself forget the spec all the time. So yeah, you don't have to remember the spec. It's on Google. And the point being that are these useful? The answer is yes. I mean, these are like the formal tools for you to think. So when you read about them, or when your class or your class material covers these, make sure to pay attention. Why? Because the thing is, these are the tools for thought. These are how you think about problems. About these things, again, your thought process is correct. You're utilizing the system properly. You're thinking about the problem in terms of a computer hardware. Like generally, you will always hear that business application or the business logic or what the software does is much different from what the hardware is trying to do. And the abstraction layer should be maintained. This should always be there, right? It's like, for example, if you're using Instagram, like Instagram mein tum photos upload kar rahe ho, that should not be a factor in any way, whether you're doing it on an iPhone or whether you're doing it on an Android. But we all know that it is a factor, right? iPhone might be more snappy. Like my Android, like my phone is a little bit older, so it's scrappy, so it does it much more slower. So is this a factor, right? And the same factor needs to be considered when you're developing a software. So it's not really completely adjunct and divided that nahi mere ko sirf business logic likhna hai, now I'll achieve business goals. So it doesn't work that way exactly. And if you're trying to do that, you'll write crappy software in general. That's like there's no alternative to it. Great. Yeah, and lastly, this. I mean, system concepts. Like this is just like a takeaway. If you guys want to take note, like whenever you are like going through your operating system and computer architecture lessons, make sure that you have a good understanding of threads, disk writes, memory management, Scheduling, that's something I did not talk about it well, but I guess you guys will anyway come across it. Basic network principles. Okay. And yeah, these are very heavily and oftenly used concepts. So yeah, and then you will come across more topics like compilers, linear algebra. I just like put a random term there from formal automata. I don't know how many of you have come across formal automata at this point? Prash, like it's in second year, right?
Actually, I guess not. I'm of ET electronics, so
Oh, yo, okay, good. I actually
I
thought that you guys want CAC. So anyway, like this is actually CAC, folks. Chomsky hierarchy is just like another meme that you will come across. Pretty annoying, by the way. And yeah, Turing machines. That's like I think Turing machine. Everybody has heard about it for some reason. So yeah, whatever the hell Turing machine is, I know. But yeah. Again, do we need to know about it? The same idea, right? It's good to know. It's not necessary. These things are good to know for general software engineering roles, unless and until your role specifically requires it. For example, my role these days require me to know linear algebra, but definitely it does not require me to know compilers, right? But linear algebra is something is a like need of the time for me. So yeah, and it's good to know because that expands your horizon. That also expands your horizon of how you think about problems and how you solve them. And the greater the horizon that you have, the more flexibility you will have in terms of how you operate, which is a really nice thing to have. Not that the industry will really entertain that, but yeah. Yeah, I'll actually stop for now, and I have some like just two more slides. Yeah. But yes, I want to really interact with you guys right now. I'll stop sharing, and yes, all questions are welcome. I've been talking for a long time, man. Whew. Okay. Okay. Questions. Everybody can either turn on their mic. No need to turn on their camera if they are, I don't know, uh, camera genic or photogenic. Is it? Like, whatever. Or non-photogenic. Uh, okay. There are a lot of people leaving a meet. That's good. Yeah, I mean that's time for like Q&A. Like I mean, just taking a break. You guys can ask your questions. I'm just waiting on the questions, by the way. Like any questions you guys have, anything. I mean, not specific to the stuff that I was talking about because the point there was to really just you guys, have you guys motivated about the subjects more than the externalities and number of things that you generally hear like people talk about machine learning, web development, app development, this, that, falana, thinka, whatnot else. Right? I was just trying to like get you guys to focus again on your fundamentals so that we don't miss out on that. Yeah. So questions.
So
Just
that
waiting.
I had a question.
Yeah.
So that from our course, whatever we learn, how do we get into data science or something like that?
Okay. Oh, how do you get into data science? So again, that linear algebra thing, right? So you have your maths courses, right? Like you have your basic math being covered out, right? In the near, I think second year itself, you have probability and statistics. Make sure that you pay attention to that. Like I mean, no need to pay attention to the teacher if you don't want, but you can always study it on your own. There is that. Linear algebra, like if you're in computer science, you're going to again come across it in one machine learning course at the end of in your fourth year, and as well as in your computer graphics course as well, which is pretty fun subject to begin with. I thought I would talk about it, but never mind. So yeah, like focusing on these subjects will definitely have you set up. Other than that, you can always explore on your own. But as for like just for like the fundamentals, like if you just focus on the math and as well as have an understanding of what's like understanding of in general algorithms plus systems, that will do the job for you, to be honest, at least to start off with, right? Because then it really like you'll be driving yourself into the going into more specifically, because it's generally like with data scientists comes the question of business context. You might have heard about it a lot of time. So what kind of field you're working on, what kind of data you're looking on, those contexts definitely helps. And you can sprinkle a little bit of your computer science understanding, and yeah, you can have a good data science career start to begin with. Yeah, and yeah, don't fall for those job headings which ask for neural network and n number of things that nobody is going to probably end up using, right? That's the truth. I mean, I'm going to give you an honest answer here. So today, like since I'm currently going through my onboarding in my current company, and we are working on recommendation systems in general. So I actually asked about the kind of models we are using, how we do modeling, and these people are using tree models in places. In critical places, they're using tree models, like simple tree models, nothing fancy, and that works. That's doing the job. That's generating revenue. So yeah, like keep it simple, keep your fundamentals strong, and that will do the job. I hope that
Thank you,
answered
Dada.
that. Hope that
Yes,
answered that, man.
thank you so much.
Any questions? Any other questions? I mean, like, we can take 10 minutes for questions, so you guys can, like, throw any questions you have. Like, be chill, man. Like, don't even think that okay, mera question kuch zyada hi dumb hoga. It's fine. It's fine. Like, I mean, I
Good
have
evening.
asked 10 more questions. Yeah, yeah. Bolo.
Yes. Good evening, Dada. In the intro, it was said that you have done projects on blockchains and all. So this is kindly a new topic in AEC, and I don't have much context regarding those blockchains technologies. So can you brief me? I have recently started blockchain and in computer networking and network security. So kindly
Hmm.
can you guide me or give me a roadmap regarding the blockchain technology?
See, I won't be the right person to give you a roadmap on blockchain technology because when I worked, right, it was what one, 2000, late 2017, early 2018, and yeah, throughout 18 mostly, and 19 we are just working on the paper. Yes. So compared to that, now the ecosystem is much more mature. If you're someone who's looking for Ethereum, so again, I'd say that jump into Ethereum. That's the most easiest one to get into. Get Truffle, get Sticks. I don't think Truffle is a pretty old one these days. I don't know what what the blockchain people are really using for development, but yeah, get those things running. But apart from that, for blockchain, you have to know few other things as well, and those comes up in your again fundamentals. Is that you need to understand network, right? Networking, right? Distributed computing, some parts of it, something like you can actually take a note of it. It's called distributed consensus or decentralized consensus, which is effectively what blockchain tries to solve in one way. Like almost every implementation is trying to solve this in some way, right? So these things you'll have to know. And as for like the development purpose, as I said, like take a deep dive into any of the stack. Like I like these days you also have Polygon. So if you look into Polygon's job portal, like their career page, you can actually get a very good glimpse in what kind of tech stack they use. So this is actually like an advice, a general advice for almost anyone here, like looking for any question, like who are about to ask any questions around these kind of things. That what tech stack they should pick, or what should they read, or what should they they should know about. Job or career pages are really great for that. Just like look into the kind of role that you want and look into the kind of the tech stack they are using. That will give you a very good idea of like what you should be looking in. And once you like start googling them, or just spend about a 3 hours in YouTube, you'll already have sort of a vague idea what you should be learning. As for roadmap, again, as I said, like I don't have any particular roadmap for that, but you can actually use these strategies. Beyond that, like as if like if you want to get into like in general what you call as a Web3, right? So that Web3 will not always require you to write write smart contracts. Not always, right? So knowing about smart contracts is another thing. You'll have to like deeply understand smart contracts. That's like if you are into smart contract development, then there is an aspect of what we call as the VM development. So this is for you, Rohan. Like I hope you know that Ethereum is actually a virtual machine, right? It executes your code. So like Polygon is a good example, who are actually trying to work on that VM aspect of things as well. So you can take that route as well, and for that you don't really have, you just have to know the fundamentals of blockchain, and then you can just utilize your Golang or Rustlang skills to actually work on the VM side of things. So again, like the blockchain ecosystem has a lot of different roles for a lot of different people, and you don't always have to work on the application layer, because remember that smart contract is really the application layer. I was talking about the application development, right? So smart contract is really the application layer. So yeah, I hope that helps. Like again, no roadmap, but these are like the general advices I can give you. Like if you want to get into the Web3, I hope that helps. Yeah. Yeah. Anyone else? Any other questions?
So Dada, it's I have a question. Means it's a what little. It's not really a tech, but it's a more of a.
That's fine.
You have been in the various roles and various fields you have explored in your means career choices and these things you have done. You have done many things. I have seen your profile and all. So I've seen that you have written papers and taken the research side also. Then ultimately got to now you are in the means in a corporate job. So means how do you contrast the life in the field of research and in the job in a corporate job basically?
Uh, yeah, okay. As for Rohan, don't
Means
call him
how has
boy.
been your experience in that means?
Yeah, so I mean, I cannot really comment on that research life because like I was not really working as a like PhD scholar, right? So like a PhD scholar can actually comment on that much better than me. But the stark difference, one difference is that the end objective is much different. So in a corporate, I'm say like corporate in general, if you're working at some place which is paying you money because it's driving a value, right? It means that your work has to drive a value. So for example, if you're working as a front-end engineer, right? And then you suddenly sit down and start researching that, okay, I want to make the next best front-end UI framework better than React on companies' time. Like that's not going to be entertained at all, right? That's just bonkers. Why would you do that? The company has different metrics, different objectives. Stick to those. So there's that. When you're researching, right? It's fine if you actually kind of sidetrack and look into other things as well, because again, like generally research happens on open-ended things, right? The problem is open-ended, right? And to be honest, here's the thing. My current role actually involves both of it. So I'm going to work with like researchers who are actually already working here, and then gradually like kind of contribute in those sectors as well, while acting as a software engineer. So it's kind of sort of a blend of both of these things. And like even here, right, in corporate setting, these people are actually trying to get and satisfy the matrix. Like, okay, we want to drive the revenue, we want to have better profitability, we want to have better user engagement. So how do I do that? Okay, I'm going to take bunch of different models, we're going to try them together, we're going to run experiments. That's it. On a research setting, things might look very similar. The only difference is that your end goal is like, I want a paper published. As for life, like if you talk about PhD, it again depends on like your guide and your work style management. I have a shitty way of managing my work, so yes, like, I always get overburdened. And the same thing in the company as well. Like it's not lot different, but it's also not a lot similar as well, because the similarities comes in how you manage things, right? And how you manage yourself most of the time. The difference comes from the the objectives in the general. Yeah, and yeah, that's how I would say it. Like, I mean, as I said, like personally, if you are doing a PhD versus you're doing a job which requires a lot of study, you might not see much difference. But if you are doing a job where you're not doing a lot of study and just writing a bunch of code and you're getting a business requirement, then it will be starkly different from what a PhD might offer you. And PhD might also, like, or PhD or in general research might also be very boring for you because all you're doing is really studying. So yeah, I mean, effectively, you're just studying a lot. You can do some kind of freelancing and like build softwares as well, but again, you're not getting paid for that. So yeah, broke and studious at the same time. In corporate, you're not broke. I mean, yeah, hopefully.
Thank you, Dada.
Oh, I hope, yeah, I hope that answers that.
Got you, Dada.
But yeah, if you do research and then join industry, then you will not be broke. Yeah, researchers are paid pretty well, by the way. But there's a hitch there as well, is that if the company believes that research is not important, yeah, your head will be cut off first.
Got it.
Okay. So I'll just quickly conclude from my end. Then I'm open to more questions. Let me share my screen and just show the last bit, which I think would be very important for everyone, especially for the jobs. And this is specifically for the jobs. All that we talked about, right? It was specifically about your CS fundamentals. And what you're looking at here, this CI/CD, Docker, Google Cloud, right? You'll even later hear something called design patterns. Stuff like these, right, are, what do I say, not part of your fundamentals. They might not even use your fundamentals, but they are important because they are something that you have to actively know and work with. It's like working with a computer, right? You're a computer science student and you're saying that I don't know how to use a computer. It will be pretty difficult. It's learnable, but it will be difficult for you. So if you start a little bit early with these things, right? CI/CD, Google Cloud, and like Docker, and like all these concepts that comes about when we talk about in general in software pipeline, it would really help you in the long term. Like for example, in your first interview, suppose right in your college placement, if they ask and you tell that, hey, I've used CI/CD to actually automate this thing. I was using Google Cloud to deploy my stuff. I was using Docker to make sure that all my team members didn't have to worry about the deployment section. And then you talk about that, hey, I use this design pattern because it makes sense, and I architected the code in such a way that we can extend it later because we are planning for that. I mean, that's a sure impressor. Like if that doesn't impresses anyone, like just leave that company, like interview somewhere else. Yeah, if that doesn't exist, just interview somewhere else, to be honest. Because this is like, as a fresher, if you bring this to the table, you're already way ahead of many people. Like you're way ahead of the competition, is what I'm saying, right? So combine all this that we talked about, this all these CS fundamentals with this, and you're rock solid, like to start with, whatever, right? And yeah, that's it. Like that was the only, like, the what you call the missing bit. Nobody talks about them. Actually, I should have also included GitHub there, because GitHub and Git is one of the like most important tool for a software engineer. So yeah, I should have included that. I don't know how I missed it, but yeah. And yeah, all the best for your computer science journey, even for the non-CSC guys, because end of the day, if you are in software, you will be exposed to computer science in one other way, and you might just end up liking the subject, who knows, or not, which is completely fine. Yeah, that's it from my end, and I'm open to any questions. Yeah. And guys, please ask questions, right? I mean, like, I know you guys might be thinking, "Ye bhai bhaiya hai," like they know, so you know some shit and this or that, and like probably thinking, should I be asking this question or not? Don't think that at all. Like, yeah, I mean, I'm giving my time, so like, why not make the best use of it, right? So yeah, questions, guys. Waiting on it. No questions.
Oh, okay. So it was great having you, Rajatda. If anybody else have a question, do share with us, and we will ask Rajatda. And like if he is considered enough, he will reply you back.
I'll just be
So
considerate enough, man. Like, why do you put it like this?
no, of course we have a busy schedule.
ठीक है, बढ़िया.
So anyway, it was great. Uh, you came and gave insights about what actually happens inside a company. So yeah, we are now motivated to learn more on these concepts which you mentioned.
To start coding for non-CSC programs, person, pick up a language and start with hello world. That I mean, like, that's the, I mean, I know the advice sounds dumb, like, but I don't really have much of there to, contribute to that answer. Like, yeah, just pick up a language, simple one, something like JavaScript or Python. That's fine if you do that. You don't have to go full, masochist hard by trying to pick up assembly or C. Like, you can do that, but don't do that. That will probably hinder you. So yeah, just pick something simple like Python. follow a book maybe. So I mean, I like for Python, I can recommend you this uh, Python the Hard Way. It's by Alan Swart or something. Yeah, Python the Hard Way. Uh, Python the Hard Way. Yeah, you can take this book and yeah, like I learned Python from this book in my class 11. Yeah, so yes, I can vouch for this. Like I actually recommend this book a lot to a lot of people. Yeah, I can actually just start from somewhere is what I would say. How many of you actually like code here, or like like are you guys not coding or just looking forward to start? Because I feel that somewhere like I did this like I just gave the entire talk a little bit way above than I should have. Yeah, sorry about that, by the way. Prayash, you should have really told me about the demography a little bit earlier.
Actually, we expected some of the more senior guys too, but
Okay, okay, got it. No, I
being
mean
not in
like,
the campus, it was actually hard to predict the motive of the
uh,
Jatta's
understood. Oh man,
motives.
no, no, no. Actually, the problem is this happens a lot of times, so it becomes really difficult. Like I was hoping that we have like people from all the different years, and that's why I like prepared it accordingly as well. That people from all the years and places can be anything. Like yeah, I know, like that's why most people are quiet. I feel they're like, भाई ये क्या बोल दिया इसने कुछ तो देखा नहीं. Yeah. Yeah, so I guess if we have no more questions, we can conclude. Like, I mean, if you guys have questions, you can post, but yeah, otherwise, I'm going to say, okay.
So, Dada, I guess it will be best that if we gain any questions, we'll forward it to you.
Yeah, sure, sure, that's fine. So
That
then
will be
conclude
the
it, right?
is Dada.
Okay, bye then.
Bye.
Bye.